In this video, we are going to discuss about source transformation. This is very useful technique. I'll discuss in a simple manner so that everybody can understand and you can solve the problems in circuit theory. Let us consider one problem. This is one source, voltage source. I have one resistance here. And then I have another resistance and one more source like this. Along with this, I have one more current source. Then I can have one resistance here, and maybe I can consider one more resistance, and then I can consider here some resistance and one source. So you can see this circuit is very complicated, looks very complicated. So how many sources are there? 1, 2, 3, 3 voltage source and 1 current source. Suppose if I provide you the values, it is 30 volt and this resistance is 3 ohm suppose, and this is 90 volt and this is suppose 6 ohm, this is 5 ampere, and now if I choose this is 3 ohm, this is 20 ohm, and suppose this is 40 volt. Then if I choose this is 2 ohm, then if I ask you the question, can you find out the current through this branch? What is the current here? So this problem is very complicated. It looks very complicated. But this problem could be solved in a simple manner just using source conversion without writing any equation. Okay, so you need to understand what is the source conversion or source transformation and how to apply it so that we can solve any problem. We'll discuss few problems here and hopefully you will be getting everything. Just follow this video neatly. Okay. Now, what is source transformation? If we have, let us consider one network or this thing, one source, voltage source with series resistance. Be careful about this one. Whenever you will consider a voltage source, so your voltage source value is V and resistance is R, and this is terminal A and B. That we can convert it to another network that is containing one current source and with resistance, and that resistance should be parallelly connected. So remember always one thing, with voltage source resistance should be connected in series, with one current source resistance should be connected in parallel. So this current source value is suppose I and this resistance. Now question is, we can convert this voltage source to this current source between same node A and B. So what is the magnitude of this current and what is the magnitude of this resistance? And it says that it is very simple thing. Its resistance value will be same as the resistance of this one. If it is R, it is also R. And what is the current? And current we can easily compute. It is short circuit current. If I make it shorted, what is the current? B by R. So that is your B by R. That's simple. If I have a voltage source, I can convert it to current source. The current source magnitude will be V by R and resistance will be same as R. Okay. For one example, easily I can give you one example. If I have this is your 10 volt and it is 2 ohm, this is node A and B, that easily we can convert to one current source and one parallel resistance. Be careful here. Every time I am saying that resistance should be connected parallelly with the current source. So this current source value will be the short circuit current that I have said. So it is 10 by resistance. So 10 is the voltage source. So this current value is simply 10 is the voltage and resistance is 2 ohm. So 10 by 2 meaning 5 ampere. And resistance, this resistance and this resistance is same. So it's complete. Okay. And if it is given opposite, meaning is that if I have one current source per resistance, if it is given, so this is I and this resistance R, that we can convert to one voltage source. So of course the resistance should be connected in series. So this is node A and B, this is also node A and B. So the question is that what is the voltage? So that voltage is nothing but this voltage at open circuit loop. So what is the voltage? So no current is flowing in this open circuit. So this current is flowing through this circuit only. So this I into R is the voltage drop across the resistance. Okay. So this voltage V is nothing but this I times R. And this resistance and this resistance is again same. Okay. So it's very simple thing. What I am saying. So if I consider this thing with one example. So I have one current source. This current source value is suppose 4 ampere and this is 3 ohm. That easily we can convert it to one voltage source and one resistance. Same node A and B. What is the value of this one? This value will be 4 into 3 because I into R. I into R is the voltage. So 4 into 3 is the 12 volt. And this resistance is 3. That resistance will keep it here. It's complete. Now to use this source conversion in a circuit, sometimes you will be getting more than one source. Then you need to understand how to combine the sources. If I have more than one sources, then only you can simplify the circuit and you can solve the complete circuit using source conversion only. So you need to understand addition of sources. So what is the meaning? If I have more than one source, so these are the two sources, they are connected one after another, voltage source, one is V1, other one is V2. So these two easily we can combine to get a single source. Is it okay? So V1 and V2, you can see that both are having the same polarity, minus plus, again minus plus. So they are going to add it. So total voltage will increase and total voltage will simply addition of these two. Okay, but be careful if the polarity is given in opposite way. So like this one, if I have one voltage source like this and another voltage source, this is negative and this is positive, like this way, this is V2 and this is V1, and this one easily we can combine and we can get one equivalent voltage source like this. So if I consider in this way, the polarity is same as for V2. So I can assume that suppose V1 is absent, V1 is not there. So this value will be V2 only. So in this case, V1 will oppose. So I'll subtract V1 from V2 to get equivalent voltage along this V2 direction. Or we can consider the equivalent potential like this. That is possible. But in that case, I'll assume that V1 is there because it is along V1. If V2 is absent, its value is simply V1. Now V2 will try to oppose, reduce this magnitude because it is connected in opposite way. So I will subtract V2 from V1. That's all. Okay, I hope this is very clear about this combination of voltage sources. Very similarly, we can get current sources, but here remember the current source should be connected in parallelly. If I have two current sources, they are connected parallelly. So this is I1, this is I2. So total one, I can get one equivalent current source, only single current source. I can get one equivalent one, that current. So here what is the current? So this side current is I1, this is I2. So net current is obviously I1 plus I2 in this branch. So that we should get here. So both the currents are added because they are in the same direction, both are upward. If both are in the same direction, they are added simply. But if one of them is connected in opposite way, like this is one current source and this is another current source. It is connected in opposite directions. In that case, this is suppose I1, this is I2. So its equivalent current source I can consider upward. In that case, what I'll do? So I'll assume that I1 is there, I2 is suppose absent. In that case, I'll be getting only I1. But in this case, I2 is leaving, so rest current is available here, I1 minus I2, because something is lost through this side, because I1 is supplied here, I2 is leaving this side, so this side branch will be I1 minus I2. So I1 minus I2 is the resulting current source. Or you can also write in this way, along downward. In that case, what I'll do? I'll consider that I2 is present. So I1 is not there, then this is only I2. But whenever I1 is there, I1 is going to reduce its magnitude. So I2 minus I1. That's all. Okay. Now we'll discuss one simple problem first. To solve that problem using source conversion. Can you try this one? So I'll give you one problem. Problem number 1. I have one current source. I have one resistance here. And suppose I am adding one voltage source here. And then I'll consider one resistance here and one more current source. Okay. And this current source value, I am giving, it is a 5 ampere. This is suppose 2 ohm. This is again 2 ohm for simplicity. And this is 2 ampere. And this is suppose again 2 volt. Now if question is, what is the current through this branch? Can I find this current? Now one suggestion is that where you need to find out the current, don't modify that element. So this element here I want to find out the current in this branch. So I will not modify this branch, because if I modify it, it is lost. It is very difficult to get that one. It is not that this would be wrong, but thing is that it will be hard to find out the current. Okay, I'll show you how to do that one. So first, this voltage source I will not modify, means this 2n potential I will keep as it is. This node is suppose A and this is B, that I will keep as it is. But I can modify this left side part, I can modify this side part, it is absolutely fine. Okay. So can I simplify this side network? Because this is one current source, one resistance, that I can convert it to one voltage source and one series resistance. Be careful. Okay, so what is that value? So this is a current source to voltage source. So this voltage value will be I into R. So this 5 into 2. This 5 into 2. 5 into 2 is 10 volt. So this is your 10 volt. Very simple. And this 2 ohm resistance, it is coming here. Now simultaneously, I can convert this part by source conversion, because this is again one current source, one prior resistance, that I can convert it to voltage source. So okay, for this one I can write one series resistance and one voltage source. Now you can see it is upward. The direction is important. If current direction is upward, this upper plate is positive. That thing. So here also, the upper plate will be positive and this is negative. Okay, so these will be the equivalent voltage source. Fine. So what is the value of this one? Again, V equals to I into R. So 2 into 2, this is 2 ohm, this is 2 ampere. 2 into 2 is the 4 volt. And resistance, this 2 ohm resistance is coming here. That is complete. Now I need to add this 2 volt source that was connected in between A and V. Now the same node is here, this A and V. So it is, this side is A, this side is B. Now I need to connect that element. So this element, there was a voltage source. This is plus and this is minus. It is connected here. And this is your 2 volt. And this side is also connected. Now question is how to find the current here. Now it looks very simple. This is a single loop. This loop is a single loop, only one current will flow, and this total current is simply total supply voltage. So here this 10 volt, 2 volt and 4 volt, we need to combine. You can see that how they are connected in this loop. So this is minus plus, this is again minus, the same direction. If I move in this side, so this is minus plus, they are going to add. So this is 10 and plus 2, because it is added, it is same side, but this time this is plus minus. If you come to this side, it will try to oppose this 4 volt. So minus 4. This is overall potential in this loop. This is 10 volt supplying potential, 2 volt is added, but 4 volt is subtracted because it is connected in opposite way. With 10 volt, this 2 volt is same direction in similar way, but 4 volt is opposite way. This is minus plus, this is minus plus, this is plus minus. If I move in clockwise direction, okay, that's how 4 is subtracted. This is total voltage by total resistance. What total resistance? This is 2 and this is 2. They are in series in single loop. So 2 plus 2. So what is the value? 10 plus 2 is 12 minus 4 is 8 by 4. That is nothing but 2 ampere. Okay, I think it is very simple. You can use these things, right? Now this kind of problem could be solved. I hope this is very useful technique that you have learned this one, but sometimes it is hard to get this, or it is very difficult to use source conversion because of certain difficulties. So one of such difficulty I will discuss and you will find it very useful. So second problem I will consider. Suppose this is one resistance. Here it is a voltage source. And so there is a resistance. And one more resistance is here. And I can consider one current source in this side And along with that, to make it complicated, I will consider one current source in this branch. Okay. Suppose for simplicity I am taking all 1 ohm. Okay. And this is suppose 10 volt. This is suppose 2 ampere. This is 1 ampere. Okay. Now, take this challenge. Can you apply source conversion? It's not very easy. Very easy to handle this thing because no source is connected directly in series. So this voltage source, this resistance is not in series because there is one more branch is connected here. Again, with this current source, no element is parallelly connected directly. Similar case for this one. So this kind of circuit is very difficult to find it out. Okay. Now the question is that, can I solve this problem to find this current through this 1 ohm resistance? So it's a hard problem, especially if you want to use source conversion. You can't use it. So what is the method? So main issue is here. This 2 ampere current source is not connected parallelly with 1 ohm or this 1 ohm. It is not that. Now, one arrangement we can do. What the things we can do? Just I will show you this method. Okay, let us redraw this circuit, this part. This is resistance, this is the resistance. And I have one voltage source here and one current source here. Fine. Now consider that this node is A and this node is B and this node is C and this could be D. So this is A, this is B, this is C and this one is D. Is fine. The 10 volt, 1 ohm each and this is 1 ampere. Fine. So far this is good. Now this 2 ampere, what I can do? I can take one equivalent circuit. How we can do that one? So this 2 ampere, from this branch one current 2 ampere should leave. So can I consider this 2 ampere current source that is leaving from this branch? Then this node, A node, is not disturbed at all. Is it fine? Because we don't wish to disturb any node. It should be equivalent circuit. So this especially to find out the current through this one. That is the requirement thing. I want to find out the current through this 1 ohm resistance. For that only I am doing these things. So this 2 ampere current is leaving here. And again, this 2 ampere current should enter to the B node. So I need one more branch here where 2 ampere current should be coming in. So here, if I consider one current source separately, it's a 2 ampere. Then this side is fine. So this side, A side and B side, both the nodes are fine because from A node 2 ampere is leaving and from B to the B node 2 ampere current is coming in. It's fine. Now I can't keep this thing open, then current will not flow. So somewhere we need to add it. But if one node, if I add it, same node 2 ampere should leave. Then there is no disturb. Suppose if I going to add this part here, connect it to here, then obviously I will connect this thing also from here because this 2 ampere is coming in and this 2 ampere is leaving from here. So effectively this node is also not disturbed because whatever current was there earlier, it will remain same because this node is not disturbed because of these connections. Because finite 2 ampere current is coming here and 2 ampere is leaving here, so identically it is not disturbed. But what is the advantage? Advantage is that right now this one I can convert to This is the current source resistance. I can convert to voltage source resistance. This is again current source resistance. I can convert it to voltage source resistance. Okay, that thing I can do, and we can simplify it and we can solve it. So can I solve this one? So can I simplify this one? This 2 ampere and 1 ohm, that one. So if I consider one voltage source and one resistance. Okay, I want to replace this thing between A and C. This is your A and this is your C. Between A and C, the direction will be, this is right side plus, this is minus because it is left to right. So what is the voltage? I into R, 2 into 1 is 2 volt. And what is the resistance? It is 1 ohm. Done? And again in the B, again this thing will convert, same thing will be getting, one voltage and one resistance connected. This is again same thing, 2 volt and 1 ohm. Fine. And rest thing now will connect. So this was connected, this source is connected, and this current source is connected. This is 1 ohm, this is 10 volt, and this one is 1 ampere. Now we can simplify. We can simplify this circuit further. How to simplify it? So these two, you can see that these two we can combine easily because both are sources. These two sources we can combine. Okay, can I do that? So only one single source. So this 10 volt and 2 volt, they are connected in the same direction. So it total is 12 volt. And this is 1 ohm resistance. That 1 ohm resistance I will keep as it is. Right now. And this 1 ohm resistance I will keep as it is. And here I need to find out the current. That is the requirement. And now this side, now be careful here about this side. And this is a pure current source. This 1 ampere is a pure current source. If anything connected in this branch, here 2 volt, 1 ohm is connected. So what will be current coming here? Again 1 ampere. Because there is no more branching. This pure current source will supply 1 ampere current. So you are going to get 1 ampere current in this through this branch. Whatever other sources are there does not matter. Okay, if anything connected in series with current source, pure current source, so this element will not have any impact because current coming to this C node will be 1 ampere. So we can remove this part. So everything we can absorb within this current source. Equivalently, it has no impact. Especially if I want to find out the current in this branch. It's very, very useful concept. Try to understand. What I am saying? I am saying that if anything, so what I am saying that if anything, if it is a current source, if anything connected here, whatever element is there, between A and B node, if this is current I, so I can remove these elements. I can simply consider that current source only. I will be getting the same effect in the, if I connect one network here, some network here, network. So in this network, I will be getting the same effect. If I exclude this element could be voltage source, could be resistance, could be combination of voltage source resistance, anything. But of course not current source. Is it okay? Very similarly, if I have a voltage source, pure voltage source, and any element is connected across it, then this N potential, if it is V, it is going to be V, it is independent of this element. So we can simply remove this one. So we can simply connect this voltage source and with this node A and B. So this is the V. So we are going to get, if I connect one network here, the same network, it is excited, and we are going to get the same result within the network. We have no issue at all. Okay, so that is a very useful concept, very, very useful concept. But provided that this is not a voltage source, otherwise there is a problem with these things. Is right? Now, what I'll do in that case, so you can see that these two networks are connected. Now we'll come to this original problem. So we have removed this element. Just we are considering only this 1 ampere current source. Okay, so we'll connect it. Okay, now we want to find out the current through this 1 ohm resistance. Now it is very simple. So again you can go for source conversion, because this is your 12 volt, this is 1 ohm, this is 1 ohm, this is 1 ohm, this is 1 ampere. So now what I can do, I can combine. I can simply combine or convert this network 12 volt and 1 ohm. Okay, so you can check the calculations if I can make any mistakes, but this is the procedure. This is 12 volt, this is 1 ohm, that we can convert it to current source. But this thing I will not modify 1 ohm. So what I will get? So can you see? I can get one current source and one resistance. Then, so this is for this part. Then I have this resistance and this current source. So that thing again I will put it. Okay. I will consider this resistance and this current source. This current source is 1 ampere. This is 1 ohm, and there I need to find out the current. Okay. Now I need to find out this one, this equivalent current source resistance. What is that? This is for this one. So what is the current? 12 volt is the voltage, resistance is 1. So 12 by 1 is 12 ampere. Okay, and 1 ohm is the resistance. So current is 12 ampere. So this is your 12 ampere and this is your 1 ohm. Now you can see that I can rearrange this thing. So all I connected parallelly, why not that these two current source I will keep it side by side. Okay, so I can consider this current source and then I can keep this current source side by side, and then I can just rearrange. Then I can keep this resistance, then I can keep that resistance. Okay, this is your 1 ohm. There I need to find out the current. Now, and this is your 1 ampere. And what is this? This is your 12 ampere and this one is 1 ohm. Okay, now it's very simple. What I can do, I can combine these two together. So both are upward. 12 plus 1 is 13. So I can consider one current source, that is 13 ampere, and then I'll connect these two So this two is, one is this one, 1 ohm, another one is that resistance, 1 ohm, and here I need to find out the current. So now I can apply current divider rule. This 13 ampere current is coming here, so it is divided by these two branch. It's equally divided because both are having the same resistance, 1 and 1. So obviously I will be, it's 13 by 2 means 6.5 ampere. If it is different, then you should use current divider rule. If this resistance is R1, this is R2, then the current will be simply the opposite resistance R1 by total R1 plus R2, this is the division fraction, multiplied by this supply current I, means here 13. Okay, so if resistance values are different, then you can use this approach to use current divider rule to find the current. I hope it is very simple. Okay, so this method, whatever you have discussed, this thing, one current source, we can split in two different sources. So you may not find this kind of idea in any book. Okay, so nowhere probably you will be finding it out, but this is perfectly fine. You can use it safely in anywhere, everywhere. So you can solve this problem by other methods like superposition principle, Thevenin, Norton, whatever it is, you will be getting the same results. Okay, so this method I'll be calling here, it's called, I'll be calling it current source splitting. Current source splitting. So this technique I'll be using. So you can see that this is very, very effective one. We can use still source conversion, you can get it. Okay, now just I'll give you homework problem. You can try for these things. So first problem, homework problem is this one, what we have given to you. Okay, so this is the first homework problem. Okay, I started with this one that I told that can you solve this problem? Obviously you can solve it. You try it and let me know what is your answer. And second problem, I can give it to you. Homework problem, very similar to that last idea. Suppose this is one current source and here it is resistance, here it is the resistance, and this side I have one voltage source, and I have one more resistance this side, but I have one more current source in this branch. This is your 2 ampere, this is 1 ohm, this is suppose 3 ampere, and this is, okay, let us take 1 ohm again to simplify the problem. This is also 1 ohm and this is 4 volt. Can you find the current through this branch? So what is the current here? So please solve these two problems. If you can solve it, your idea is clear. You will be able to solve any problem using source conversion or source transformation. Okay, so thanks for watching. Please let me know if you need any more help, and I'll be trying, or I'll try to upload more videos based on your requirement. In the comment, let me know which video you need more. Okay, what kind of video you want, so that I can help you. Okay, and if you find this channel useful, If you want to get more number of videos from this channel, you may subscribe it, and you may like this video as well if you have enjoyed this one. So thanks for watching.